Well, a loop has a Boolean expression in it, which means that it's always testing every time you go through the loop. It has true and it has false. So as long as this test, if I is in this range as true, we continue our loop. As soon as that's false, we exit the loop. So it's very much like an if statement, but you can think of it as a repeating if statement. Once the if statement is false, we jump out of the loop. Now the range function is kind of particular to Python. I can't think of another equivalent in other languages. This automatically gives us the numbers 0 through 9. In computer languages, sometimes it includes 1, sometimes it doesn't include this one, sometimes it doesn't include both, sometimes it includes both. When you do rounding in Python, it includes both of them. No, it's random numbers that include both of them. In some languages, it includes this one, but not this one. So there's different rules. But what this will go through is this is something that's called an iterator. Have I said that word over here? Maybe, maybe not. An iterator is like an internal looping mechanism built in that you don't have to loop. That's not a good description, but that's the best I can think of. So in the range code, it keeps track of this loop for you. It says, oh, the first time you ran me, I'm going to give you a 0. Oh, this is the second time, so I'm going to give you a 1. And this is the third time. So this is keeping track and putting the new value into here. So this is keeping track of each iteration. Iteration means each repetition, but we like to use fancy words sometimes in computer languages. So iteration is the fancy word for looping or repeating. In programming, we call it iterating. And something that can iterate is called an iterable, meaning this has a looping structure built in it. We don't have to program the loop. So each time we go by this guy, it sends out a different number because it's tracking each iteration and sending out a different number until it gets to 9. And then it's done. It says, I am at the end. I am now false. There's nothing else to go in there. Let's get out of this guy. Yes? No? Okay. So you can range up and down in any direction. This goes from 9 to 0. I can do -2. I can do 2. I can like mix and match these guys however I want to get any range of numbers that I want to get. There we go. So 10, 8, 7, 6, 2. What if I want to count by 5? There we go. And what if I want to go, what if I did that? Would anything happen? Starts at 10, ends at 0. Wouldn't work. Yeah, nothing happens because it's not the right way around. This is the starting, that's the ending.
Why did you make it -5?
If I made it -5, we're fine because we're going this way. If I have 1, 0, and 10, I'm going this way. So you can go in any direction.
So what's a -5 for you?
I'm starting at 10 and I'm going down to 0. If this was 0 and I had 10 over here, I'd be starting at 0, going up to 10. I can't use a negative increment when I'm starting at 0 because -5 is not part of my range. The range is from 0 to 10. -5 does not fit in there. It's outside the range. So if I run this, nothing will happen. Nothing happened. If I put something here, this is the step value is what that's called. If I put a 2 in here, then from 0 to 10, I'm going to step in positive increments. But I can't step in negative increments because there's no negative numbers in my range of numbers I'm working with.
Okay, so my question, is it going to be like 2, 4, 6, 8, 10?
Yeah.
Oh,
Yep. That's what it's going to do because I'm doing a positive number. But if I do a negative number here, what's going to happen, Eliza? If I do a negative number instead of a positive number, what's going to happen?
it shouldn't run.
Hmm?
It shouldn't work.
It doesn't. Nothing prints. And that's what this is, so you can do things in any order that you want to get a sudden, a bunch of range and numbers very quickly. I think that's where I started. Yeah, step 2. So beginning and how you step through it. There, that was my original, I think. All right, and the while loop is our friend. Use a lot of menus. This one's nothing else complicated about that. It's the same idea. While this is true, we stay in the loop. As soon as this is false, we exit. Okay, keep going. We know about break, right? If we're in a loop and at some point we want to jump out of the loop, break exits the loop immediately, does nothing else. It says goodbye. It may be that if we encounter a certain condition, we want to go to the beginning of the loop. Well, what is this going to do for us? While our count is less than 10, we're starting at 0 and it's less than 10, isn't it? So far, so good. If the count modulus 2, okay, if I have my first number is 0, what's the result of 0 modulo 2?
0.
Yes. Owen just had his hand up like that. He was trying to be clever, I think. Did it work, Owen?
Worked.
Yeah, okay.
Without giving everything else.
Okay, so if the count modulo 2 is not 0, right? So if our modulo is 0, does that make this true or false? If our answer is 0?
Is equal to 0?
If our number coming in, our count coming in is 0, and 0 modulo 2 is 0, right?
I think I'm confused. Saving him.
That means not equal to 0. That's what this does. It's a reverse condition.
Right.
This means, is it equal to 0? This means, is it not equal to 0? So is 0 not equal to 0? Is that true or false?
That's all.
Right, so we don't go into this, we jump and we keep going. We add another number to it. And then the next time around, it's 1. Well, is 1 modulo 2, what's the answer to 1? Well, we'll jump up to 3, for example. What's 1 modulo 3?
1.
3 modulo 2. Sorry, I gave the answer and not the question. So it's 1. Is 1 not equal to 0?
Yeah.
It isn't. So we go into here, we increase our count, and continue says we go past this, we don't print the count, we go past this and start again. So what are we printing out here? What is going to happen when we run this program? In the instructions, I just say continue causes the code to go directly to the beginning of the loop, but I didn't say anything in there about what we're having come out of this. So what are we having come out of this?
The one that is true.
It is, but what's going to be the sequence? If it's modulo, if the modulo of it is not 0, so if I have a 2, modulo 2, that gives me 0, right? If I have 4 modulo 2, that's 0. If I have 3 modulo 2, that's 1. If I have 5 modulo 2, that's still 1. No, it's 3.
Yeah.
Yeah, it's 3, sorry. So what am I getting?
No, it'd be 1.
Is it
5
1?
modulo 2.
Yeah, it's 1. So I'm getting, what am I getting out of this?
Well, all the even numbers. It's printing all the even numbers.
It is?
Yeah.
So when we have kids come in and they're standing there and they get fast and they think.
Is that a convoluted way to do it, kind of? Yeah.
It'd be easier to go forward. So.
Right, but in this case, I was trying to figure out some way to demonstrate continue. And I also wanted to include this because you will see this, and not equal to always messes with my brain to try to figure out what the real answer is. But what you do is remember, what does this evaluate to? Does this evaluate to true or is it false? Once you remember that, then for me, it makes it easier. Okay, I have a for else one in there, but I have never ever found a time to use for else or while else, so I'm tempted to take that out, but you may see it later on. All right, let's close that, and we're going to go to a very important security concept.